Hello students, in this video we shall discuss a very important theorem from the chapter Quadrilateral. This is basically theorem 8.9. The statement goes like this: the line segment joining the midpoints of two sides of a triangle is parallel to the third side. This is also called a midpoint theorem. You will come to know why when I start explaining. So what it basically says, if there is a triangle ABC, so let's say ABC is a triangle and D and E are the midpoints of AB and AC respectively. So if I join DE now, D and E, so I get a straight line DE. So the theorem says this line that joins midpoint, this DE, is parallel to the third side. Which is the third side? BC, isn't it? So DE is parallel to BC. D is the midpoint of AB, E is the midpoint of AC, so DE is parallel to third side, that is BC, right? So this is what we're going to prove now. This is called a midpoint theorem. So let us go to the proof now. Let's take a proper figure now. Let's say this is my triangle ABC, and D and E are the midpoints, so DE. Okay, so basically what is given is that D and E are the midpoints of AB and AC respectively. So you will have AD equal to DB because D is the midpoint, and you will have AE equal to EC because E is the midpoint. Okay, so what you need to prove? You have to prove that DE is parallel to BC. To do this, you have to do a small construction. Construction is, through C you have to draw a line parallel to BA like this, and then you have to extend DE so that it meet this line at F. Okay, so through C CX parallel to BA is drawn. DE is extended to meet CX at F. Okay, following till now? Alright. So we have two triangles now, ADE and CEF. Okay, so now I have to prove these two triangles congruent. Let me redraw the figure now. ABC, DE. This is the construction. F. Okay, done. Okay, so now in triangle AED and triangle CEF, we have this angle equal to this angle. So I have AED is equal to CEF. Why? Vertically opposite angles. Okay, we also have AE equal to EC. Why? It's sort of given because E is the midpoint, isn't it? Okay, and we'll have this angle equal to this angle. Why? I have DAE equal to ECF. They are alternate angles because BA and CX are parallel. So these two triangles ADE and CEF are congruent by, as you can see over here, angle side angle. Okay, once they are congruent, I can write DA equal to CF as CPCT, and I can also write DE equal to EF as CPCT, right? So what I have is that this side DA is equal to CF, alright, and DE is equal to EF. Okay, please focus because the figure is getting complicated. All right, till now it is done. Now if you look at the figure, can I say AD is equal to BD? Because obviously D is the midpoint, and we have just proved that AD is equal to CF. Okay, so if I continue from here, so I need to redraw the figure quickly so that you people can follow. All right, don't think it's too complicated, it's actually very easy, it's linear. All right, so we have AD equal to BD. This is basically given because D is a midpoint, and we have just proved that AD is equal to CF. Just proved simplicity, using simplicity. That means my BD, not triangle, BD line segment is equal to CF. That means these two sides are equal. But BD and CF are also parallel, because essentially, why? Because BA and CX are parallel. BD and CF are just parts of them. Okay, now this condition is very important. We have to use 8.8 now. One pair of side equal and parallel. BD equal to CF, BD parallel to CF. So by using 8.8, what I can write? I can write BD FC is a parallelogram. Done. So if BDFC is a parallelogram, then obviously your DF is parallel to BC. Opposite sides of a parallelogram are equal. So DF is parallel to BC. That means DE is also parallel to BC, isn't it? This is why I needed to prove, isn't it? DE is parallel to BC. Alright, this is a proof of theorem 8.9. Now there is another interesting part. DE is parallel to BC. Okay, now DE is half of DF. Please look at the figure. DE is half of DF and DF is equal to BC. Okay, so now let us do this corollary part. So this becomes your corollary. So this is your triangle ABC, DE, construction F, isn't it? We have just proved that DE is parallel to BC, but DE is half of DF because E is the midpoint. CPCT we have done, isn't it? And because it is a parallelogram, DF, opposite sides are equal, so DF is BC. So basically we have DE is half of BC also. Right? Two things are happening. One, DE is parallel to BC and DE is half of BC. Okay. So the first one, D is parallel to BC, is the midpoint theorem. D is equal to half of BC is a corollary of the midpoint theorem. Okay. It is a lengthy one. I hope you people have understood all the terms and statements that I have written over here and the reasons why I am writing so. In the next video, we shall do the converse of this midpoint